Hey guys, so here's our 3.2 video on graphing. I'm actually not going to be able to probably get through all these examples, but give you the quick rundown. So we are graphing radical functions, square root and cube roots, which means when we decide to pick values for x to plug in, we want numbers, since we're not going to have a graphing calculator, that we can take the square root and cube root of. So that is why you are seeing the following numbers here. Okay. All right, so let's start with the square root. So we have now learned, yes, we can take the square root of a negative number, -9, -4, -1. However, when we graph, imaginary solutions will not make it on our graph. The graphing is only for real numbers. So these numbers will actually be obsolete, and the first number I can take the square root is 0. So here are the following square roots. I would assume you probably know these numbers. Now with cube roots, I can take the cube root of a negative number. So hopefully you know these cube roots as well. So I'm just going to write them in. And if I graph them real quick, so I'm just graphing what I see over here, 1, 2, 3, 4, and 9, 3. This is the shape of a square root function. And if I graph these real quick, 10, 9, 8, this is the shape of my cube root function. So the big thing to note between the two is that the square root function does have an arrow on one side, but a dot on the other side, whereas the cube root function does have arrows on both sides. So the reason why that's important is when we get into our domain and range. So in my class, we always mark our important points. So one of those is where we start and where we end, and where we start and where we end. And I got to put another negative infinity here. So when I do the domain of my square root function, the smallest x is 0, the biggest x is infinity, and my range is the same thing, smallest y to biggest y. Is it one-to-one? Yes, this is one-to-one because it passes the vertical line and the horizontal line test. And in my cube root function, if I did my domain, or I could write that funky R for all real numbers, and then the same would happen for my range, and yes, this is one-to-one. All right, so let's graph a couple now. These are the parent functions, and let's talk about what happens when you involve your A, H, and K. So in my class, we know that somewhere up here, this is where we will see our flip, our stretch if that A value is bigger than 1, or our compress if that A value is in between 0 and 1. Remember, A is never technically negative. The negative is what causes the flip. And that's the same thing over here. H, I told my students, is always in the house. So in this chapter, our house is in the square root. A house has walls. It contains something. So this is where we take the opposite, and things then move left to right. And then K is our up-down number without taking the opposite. All right, so the adding, subtracting are the H and K. The multiplying value is our flip, stretch, compress. So the first thing that's pretty important is just, do you know your shape of your function? So just keep that in mind. So if I were looking at, let's say, the left 2, or actually, let's do the right 2. The first one is a square root. It is flipping, so it's actually going to go like that. And on the cube root, it doesn't flip. It's going to kind of stay like that. That's not a very good shape, but oh well. Identify our transformations. That's our second step. So we are going to have a flip. We are going to have a stretch. We are going to have a right 4 and an up 2. On the other one, we are going to have a stretch. We're going to have left 3 and up 1. So with that, I need to get my points. So I'm going to start. This is how I showed my students to graph. So this is a square root. These are the numbers that I can take the square root of without a calculator. And I'm going to get 0, 1, 2, and 3. So from there, what I have my students is apply the stretch first. So the stretching, compressing, flipping always affects the y values. So I'm going to apply, I said stretch, but my flip and my stretch to my y values, which means I just take all of these and multiply them by -2. So again, that's this -2 to get some new y values. And my new y values then will be still 0. Let me make a new column. -2, -4, and -6. And then what we like to do is cross out the old y values so we just don't get confused. And so what I'll do is I'll start at 0, 0, but then that point is going to go right 4 up 2. So if I go right 4 up 2, it ends up right here. And then this purple dot that I have isn't needed. And then I just do that with all my points. I go to 1, -2, and I count right 4. And hopefully I'm getting these. This is a little hard. So here's 1, -2. And if I go right 4, and then down 2. Again, this is a little hard to do on here. Right 4, down 2 is about there. And then I'll take 4, -4. And I'll go, sorry again, 1, 2, 3, 4, 1, 2. I might be a little off on some of these because I just can't quite see where this point's ending up. And then I would go to 9, -6, and I would go right 4, down 2, and let's say that's about here. And then I think I might be off on one of these points, but hopefully you get the idea of it. Okay? So if I do the one below it and being a cube root function, here are the x values I should be able to take this cubed root of. So I am leaving out the 27s because I would never be able to fit 27 on this graph. So here are their cube roots. And because I have a stretch, I'm going to apply the stretch to all of these. And if this were a half, then I'd put a half and multiply with a half. So then I get these new y values. And then I don't need these old y values. So again, I will take these points. I'm going to move them all left 3, up 1. So if I start, I'm actually going to start at the 0, 0 point, and I'm going to go left 3, up 1. And then I'm going to take my 1, 2 point, and I'm going to go left 3, up 1. So again, I'm at 1, 2, and I just count left 3, up 1. And then I'll get my other points slowly and surely. Again, that one's a little off, like there. And then I'll do the 8 4s. And I will go left 3, so 1, 2, 3, and up 1. I think that's about it. And the other one won't quite fit on the graph paper, but I can kind of imagine where it is. So if I'm at -8, -4, and then I count left 3, up 1, hopefully you can see that little green dot there. And it basically goes something like that. Again, I didn't hit the points. It's a little hard to graph on this computer, but that is basically how we graph. If you would like for me to show you some more examples, I can walk you through the other two, but hopefully that's enough. That's it, and you can start some practice.